Hi there, I'm Dr. Ben Roemer, President ad interim of UTMB in Galveston. Our institution is honored and thrilled to sponsor the Thought Leaders Lecture Series. As an academic medical center that provides comprehensive, high-quality, and accessible care across the entire Bay Area and down into Galveston, we are proud to partner with Space Center Houston to bring you these stimulating talks featuring some of the best, brightest minds of our time, sharing their views on a wide variety of complex scientific topics. While the COVID-19 pandemic continues to unfold and dramatically change our daily routines, teams of individuals across our institution are working to counter the virus on all fronts. We're caring for those impacted by the disease, testing those who are sick or who have been exposed, and working hard in our laboratories to better understand how this virulent threat behaves. We hope that these engaging and educational lectures provide you a needed respite during these trying times and serves as a reminder to you that humans have the capacity to do great and brilliant things, even in the face of adversity. Thank you and be well.
Hello, I'm William T. Harris, President and CEO of Space Center Houston. We're a nonprofit and dynamic science and space exploration learning center. We're also the official visitor center for NASA Johnson Space Center. We share the story of human spaceflight with more than 1.25 million visitors annually from around the world. Thank you for joining Space Center Houston's Thought Leaders Series, Astronaut Selection and Training Process, presented by UTMB. Our Thought Leaders Series brings you space and science experts from around the country to provide insights and perspectives on space exploration. This year, we're celebrating 20 years of continuous human habitation on the International Space Station. Our Thought Leaders topics honor the ISS and its significant achievements and benefits to humanity and space exploration. We greatly appreciate you joining us today. We understand that everyone is facing challenges during this pandemic crisis. I'd like to extend heartfelt special thanks to all the first responders and healthcare workers serving on the front lines during this unprecedented time. As we navigate this unique period, Space Center Houston is committed to supporting our community with authentic science learning experiences. Though temporarily closed, we look forward to reopening Space Center Houston in the near future. The health and safety of our guests, crew, and community is our top priority, and providing a welcoming and safe experience will require new procedures, equipment, and staff training. We will announce a reopening date on our website and on social media very soon. While our facility is not open to the public, Space Center Houston is offering robust virtual learning experiences. We've launched a new challenge series as part of our Innovation Gateway Community Science Initiative, presented by BHP and supported by Repsol. Anyone can participate. In the current challenge, we ask you to design meals for astronauts on the International Space Station. You'll have to ensure it's a balanced meal and meets the ISS food system guidelines. I encourage you all to compete in our new Innovation Gateway Challenge at spacecenter.org/innovate. We also have a virtual campout coming up during Memorial Day weekend. Gaze at the stars with us and we'll make science come to life in your own backyard. Take a virtual tour of the museum through our app. You can download Space Center Houston free on any app store and experience augmented reality, videos, and audio stories about the future and historic feats in human space exploration. The app is available for Apple and Android devices. Learn about activities students and families can do together in the Try This at Home blog series, and you can follow Space Center Houston's blog on spacecenter.org. For our latest engaging content, again, visit our website and connect with us on social media. We look forward to reopening and welcoming our guests back to the museum very soon. Until then, please enjoy exploring space and science through our digital resources page, which is, again, spacecenter.org/resources. To help us bring this content to you, we ask that you consider becoming a member or making a donation to help bolster and expand our digital delivery of education resources for the community. Again, you can make a gift or join as a member through our website. And now on with our panel, Astronaut Selection and Training Process, presented by UTMB. We're excited to learn insights about how astronauts are identified and selected, the training process, and how equipment and environments are designed and built to enable productivity and well-being for humans in the dangerous environment of space. We're so thrilled to have three distinguished panelists joining us today. They are Ann Roemer, who is NASA Johnson Space Center Astronaut Selection Manager. Ann joined NASA in 2000 as a Presidential Management Fellow. She currently is NASA Johnson Space Center's Astronaut Selection Manager and Director of the Human Resources Office. In her role, she's responsible for ensuring workplace capabilities by attracting, retaining, and developing approximately 3,000 civil servants, supporting human spaceflight and NASA's plan to return to the moon and plans to go on to Mars. She leads stewarding a workplace culture of inclusion and innovation that fully engages the human spaceflight team. Her previous positions at JSC include Deputy Director of Human Resources Management Office Branch Chief, the Executive Resources Program Manager, and the Cooperative Education Program Manager. Ann holds a Bachelor of Arts degree in International Relations from Roemer College and a Master's of Arts in International Administration from the University of Denver's Graduate School of International Studies. She's also received the prestigious NASA Outstanding Leadership Medal. Our second panelist is Dr. Kjell Lindgren, NASA astronaut. Kjell spent most of his childhood abroad and returned to the US to complete his education, including undergraduate degrees from the US Air Force Academy, a doctorate of medicine from the University of Colorado, and a master's in public health from UTMB. He's a board certified in emergency and aerospace medicine. After serving as a deputy crew surgeon for STS-130 and Expedition 24, he was among 14 selected to serve in the 20th NASA astronaut class in June 2009. Dr. Lindgren flew on Expedition 4445 and logged 141 days in space. He's participated in 2 spacewalks and in more than 100 different scientific experiments. Our final panelist is Todd May, KBR Senior Vice President of Government Solutions, United States. Todd's role is leading a solutions provider to the civil, military, and commercial space industry. Through a Space Act agreement with NASA Johnson Space Center, KBR is the only company providing human spaceflight operations services to commercial companies using NASA facilities and capabilities. Todd has a very distinguished career, having worked with NASA for 28 years and retired as in his last position as from NASA as the director of the NASA Marshall Space Flight Center. Throughout his career, Todd held numerous program management and leadership positions, including program manager of the Space Launch System, SLS, program manager of the Discovery and New Frontiers Robotic Exploration Programs, program manager of the Lunar Precursor Robotics Program, project manager for International Space Station Quest Airlock Development. Todd earned a bachelor's degree in materials engineering from Auburn University. He's also received many prestigious awards, including NASA's Exceptional Achievement Medal and Distinguished Service Medal. Our panelists will now provide more information about their backgrounds and the scope of their work, followed by questions, along with some amazing imagery. Prior to this program, we asked the public to submit questions, and we had a very robust response. So we'll try to answer as many of these questions as possible during our program. So now let me turn the microphone and screen over to Ann Roemer. Ann?
Thanks, William. Thank you for the introduction, and thanks to Space Center Houston for hosting this event. I'm happy to be here today and look forward to a great conversation about astronaut selection and answering any questions that come up. William did a great job of introducing me. I'll go over just a few things about how I ended up at NASA and specifically in the astronaut selection role itself. I actually am originally from the great state of Ohio. I was born and raised there and grew up in Findlay, Ohio specifically. I pursued an undergraduate degree in international studies at Roanoke College, which is a very small liberal arts school in southwestern Virginia. And then went on to pursue my master's degree also in international affairs at the University of Denver at the Corbell School of International Studies. I did not have NASA in my sights at all as a career option, being a firm liberal arts student. I actually specialized in Southern African, Sub-Saharan African studies, even within my international affairs degree, and there is not a space agency yet in Africa. So I ended up at NASA really by accident through a program called the Presidential Management Fellowship Program, which is a government program designed to get graduate students to go work for the government. So it was probably one of the luckiest days of my life when I bumped into the NASA recruiter, and 20 years later, I'm still at Johnson Space Center, and now I'm responsible for the human resources function at JSC and, of course, the astronaut selection. I started off in terms of how does one get into astronaut selection. I was lucky enough to be asked to be the HR representative for the crew office, and so I was able to build strong relationships with many of the astronauts at the time, and ultimately that opened the door for me to pick up the NASA's astronaut selection program. NASA had the same individual responsible for astronaut selection since the first selection of shuttle astronauts back in 1978. So it was an honor to be asked to carry on in his footsteps and to continue the great mission of selecting amazingly qualified folks for astronaut selection. So astronaut selection, what's required? It's pretty straightforward. We require U.S. citizenship for our astronauts, given that we're a government agency. We do, starting with this selection cycle, have started requiring a master's degree in a STEM field. So, that covers a wide variety of technical disciplines, the STEM arena, but that is a job requirement. And then we also require a minimum of 2 years of professional experience beyond the pursuit of the STEM degree, the master's degree, to be qualified, minimally qualified to apply. What that means is if we look at the last 2 selection cycles, we saw 18,300 folks apply at the last selection cycle that we had that culminated in the selection of 12 astronauts. And we just closed an application window this March 31st and had over 12,000 individuals apply. If you're wondering what that means, right, that means a lot of people locked in a conference room reviewing applications. And so you can see this one actually is from the selection cycle in 2017, where we start just by reviewing applications and making sure that people who applied met those basic qualifications that we. A little interesting tidbit about this particular announcement is that we have always historically had roughly the same percentage of people who aren't qualified, who maybe have a history degree or some other type of non-qualifying experience apply. This is probably one of the few announcements out there where people actually call and request the rejection letter. So we get a large number of people who actually call and apply specifically so that they can get a rejection letter stating that they were not picked to be a U.S. astronaut candidate. So that's something interesting. We always also typically see quite a few creative entries with people writing their applications as if they were creative writers. I remember a great one that I read. They made up that they worked for NASA, which was secret NASA, and they were responsible for finding the gold on the moon. Yeah. So this job is a joy because you come into contact with thousands of great Americans' applications, and it's a pleasure to read through all of them and know how much it means for people to be able to pursue their childhood dream to be an astronaut. Beyond after we kind of assess minimum qualifications, we actually turn the applications for those that are really qualified over to the astronaut office itself. We use the astronauts as basically subject matter experts to review those files. And right, they're then responsible for looking for relatable experience, right? We don't see too many applicants who apply who have had past astronaut experience. So we're looking for other skills and capabilities through their application that demonstrate that they could be good astronauts and that we could train them in how to be an astronaut. Certainly this after we go through that phase, we actually go through 2 rounds of interviews to interview candidates. We roughly invite around 120 folks to interview for the first time, and then between 40 and 50 get invited for the second round. The picture that you'll see with folks out in the yard, beyond just going through your normal job interview process, we actually put candidates through a bunch of situational experiences where we're trying to assess, right, their ability to be a good team member, their ability to be a good leader, a good follower, how well do they communicate overall, and then in stressful situations, etc. We even go so far as to do an extravehicular activity aptitude test. So on top of just being a normal job interview, we're doing a lot of other things with the candidates so we can really see the capabilities and the skills that they bring to the table and how they perform in a team environment. I think one of the most important qualifications we're looking for is the ability for folks to be a good teammate in a crew situation. And so that tends to be what we focus on a lot. Certainly, as we finish that process, right, at that point, we're talking about the best of the best that we've had the opportunity to meet and interview. The board, the Astronaut Selection Board, ultimately is responsible for making a recommendation on selection, and that gets really difficult. There are, again, far more great candidates that we wish we could hire, and getting down to that final group is a challenge. And so you can see in the pictures, this is the most recent class of 2017. We selected 12 individuals. And it's an exciting opportunity. I've been blessed to be able to sit on the phone calls where we get to call someone and tell someone they've been selected as an astronaut. And the range of emotional responses that you see is something that I'll carry with me my entire career. It's phenomenal to watch them get to achieve what for some of them has been a dream since they were children. So, it's a complicated multi-phase process. Each selection cycle is a little different. We really rely heavily on the astronaut office throughout the process. And, we do our best to treat every application that we receive as someone's childhood dream. So, that pretty much sums up astronaut selection from a high level overview. So William, I'll turn it back to you.
And that was absolutely fascinating. Thank you so much for giving us an inside perspective on how that process works. And it was also interesting seeing some of the images on the selection process and how that screening takes place. And now we're going to hear from an actual astronaut, Dr. Kjell Lindgren, who's going to talk about his experiences being selected and going through astronaut training. Kjell.
Thank you so much, William, and I'm excited to get to talk on the other side of the selection process and talk a little bit about training. And just to kind of add to what Anne talked about, I think all of us that get selected and have the opportunity to train as astronauts are feel incredibly grateful for that opportunity and recognize that any number of the folks that we went through that selection process with could do as good, if not a better job than we're doing. And so I think that really sticks with us as we train and prepare to fly because we recognize what an amazing opportunity we've been afforded. Well, as William already introduced me, I am an astronaut here at NASA Johnson Space Center, and I also want to just add a big thanks to Space Center Houston and UTMB. I'm really excited to be a part of today's panel. Now, I joined NASA in 2009, and after several years of training, I launched the International Space Station in the summer of 2015. I spent 141 days on the International Space Station, and I worked on over 200 experiments while I was there. I got to do 2 spacewalks, and it was a lot of fun because I was a part of Scott Kelly's 1-year mission during that time. Now, currently, I'm serving as a backup to the 2 crews that we have training on the SpaceX Crew Dragon. So Bob and Doug are getting ready to launch here at the end of the month, and then the long duration Crew 1 mission will launch hopefully by the end of the summer. And we're very excited about those opportunities. I graduated from the Air Force Academy, and after separating from the Air Force, I went to medical school at the University of Colorado. I trained in emergency medicine in Minnesota, and then still had this desire to participate in space. And so I went on to do a second residency in aerospace medicine, and then got a job as a flight surgeon at NASA. And that's then when I applied and was very fortunate to be selected into the 20th astronaut class. I have wanted to be an astronaut for as long as I can remember, so it's a privilege to serve in this capacity and a privilege to share this experience with you all today. So I think most of my colleagues will agree that getting to live and work in space is the best job off the Earth, and that training to fly in space is the best job on the Earth. And so this photo that you see here is a picture of our 2009 class, and we look so young, so naive to the task that lies ahead of us. You know, when I look back at the training that we accomplished to prepare to fly on space station, it's a little overwhelming to consider. You know, it's a massive amount of knowledge and skills that that we not only have to become proficient in, but to master in preparation for flight. And like any major undertaking, we do it, as the Russians would say, shag za shagam, or step by step. And so that is incremental learning, breaking it down into individual little tasks and just layering on top of those tasks. And so as astronaut candidates, the 2-year period of astronaut candidate training, we have 5 major disciplines that we're responsible for. And those include T-38, robotics, space station systems, spacewalk training, and then the Russian language. And we all started Russian language training on day 1. And I think most of us would agree that it's one of the more challenging aspects of our training flow. So as that class, after we started in August of 2009, we dove right in. And the first activity that we all engaged in was land survival training with the Navy up in the Northeast. And so this was a tremendous opportunity. We learned some important skills, but really served as a great class bonding experience. And then for the half of the class who were not pilots, we were sent to Pensacola to do accelerated aviation training with the Navy. And so this included water survival training. And this is really a great example of that incremental training. So on one of these days, at the end of the day, we were going to be dunked in the helicopter dunker there on the right, blindfolded. We'd hit the water, strapped in, flipped upside down, and have to swim out after opening a window and make our way to the surface. Now, if we had done that at the beginning of the day, there's no way any of us would have been successful. But the Navy has this great way of helping you master individual skills that build up to this larger skill. And that's a great kind of a microcosm for space station training. So we further prepared for our aviation training with hypoxia familiarization in the altitude chamber and ejection seat training. And so this was all part of an introduction to aviation in the T-6 training aircraft. And this is the primary trainer for both the Air Force and Navy pilots and backseaters. So we studied aircraft avionics and systems and practiced navigation and communication in the simulator and in the aircraft, where we learned basic flight skills and how to work as a crew. And so flying in the T-6, that 6 weeks curriculum was really all in preparation then for our training back at Johnson Space Center in the T-38. Now this aircraft and this flight training really serves as the foundation for our space flight readiness training. And so that is, the T-38 puts us in this operational environment where we have to work well as a crew, both in normal and emergency situations. We practice efficient and effective communications and as a crew and also with the outside world. And we have to follow procedures and make decisions that have real life consequences. And so the importance of this T-38 training really cannot be understated or overstated, sorry. In addition to flying, we train in robotics and how to fly the space station's robotic arm, not only to capture cargo vehicles, but also to fly crew members around during a spacewalk. We start with computer-based simulations, and then we move on to using the hardware and displays that we'll actually use on orbit. We also spend a considerable amount of time studying space station systems. So we have to know how all the various systems in the space station work: the thermal, power, command and control, the environmental control system, how they work normally, and also how they respond and how to respond when these systems break down, how to work with the systems through our computers, and then also how to repair the hardware by hand. And then finally, we spend hundreds of hours at the Neutral Buoyancy Laboratory, the huge pool that we have near JSC, learning how to do spacewalks. We learn how to operate in the spacesuit, how to move around the space station, how to use tools and safety tethers, and also how to respond to emergencies. This is a critical training environment to train us how to do one of the more dangerous activities that we'll encounter during our expeditions. And just like a real spacewalk, it's a phenomenal experience, but it is also physically and mentally challenging work. So in addition to these 5 core disciplines, our class underwent significant geology training. So we joined NASA back when the moon mission was on the near horizon. And so of course, we're all super excited by the nation's current goal to return to the moon and to aim for Mars. Now, as a part of our astronaut candidate training, we also had the opportunity to visit NASA centers all across the country and gain an in-depth understanding of how we work with these other centers to explore. After about 2 years of astronaut candidate training and attaining a basic mastery in those 5 core disciplines, we graduated and joined the active astronaut corps. We picked up technical jobs supporting the folks in the office that are flying or preparing to fly. But in addition to those technical jobs, we occasionally have the opportunity to use all of these skills that we have learned and to integrate them in the field. And so in environments like NOLS, the National Outdoor Leadership School, we train there to learn how to practice leadership and followership, and how to do those things in this austere and often challenging environment. And so this NOLS training is really a foundation for the practice of what we call expeditionary behavior, or guidelines or a culture for how we treat each other in training and how we live and treat each other on orbit as members of a space station crew. Now, I've already talked about a lot of the technical skills, working with hardware, and it's here that we're learning some of those soft skills, interpersonal relationships and followership and leadership, things that are really critical to living in this contained environment on the space station for long periods of time. We have the opportunity to train in other spaceflight analog environments, places that simulate some of the challenges that we encounter in life in low Earth orbit. So for example, my classmate, Dr. Serena Anand Chancellor, spent 6 weeks living on the Eastern Antarctic ice sheet, recovering meteorites with the ANSMIT program. We have astronauts exploring unmapped cave systems in Europe with ESA's CAVES program. And then we also partner with Florida International University on the NEMO program. This is the NASA Extreme Environments Mission Operations program, where we have crews living in the Aquarius underwater habitat, running a space station timeline, conducting simulated spacewalks, and performing real science, some of the science that we're actually preparing to send to the space station in this underwater laboratory. The Desert Rats is another analog that was conducted on the Black Point lava flow in Arizona, where we test out equipment and operational strategies for future planetary exploration. So these opportunities to use our skills in these analog environments are really invaluable preparation for ultimately being assigned to a space station mission. And so for me, I was assigned in 2013 and began a 1.5 years of mission-specific training to prepare for my time on the International Space Station. So think of all the breadth of information that we have to consume and master. And these are just small parts. For example, we have to learn how to operate a Russian launch and entry suit and to trust that spacesuit in a vacuum chamber. And so the Sokol suit or the Falcon suit is one small part of an integrated Russian spaceflight system. And other preparations for that system include having to prepare for contingencies. For example, what if the Soyuz capsule lands in water? So we have to do water survival training in the Soyuz capsule. We do winter survival training in the forest outside of Star City. And so spending 3 days and 2 nights in the woods, let's just say that I have immense respect for the Russian winter. Over the course of our mission-specific training, we spent several months in Russia training in the Russian segment of the space station and also on the Russian Soyuz capsule. We have to take tests at the end of our training flow to be certified to fly. So we have tests both in the Soyuz and in the Russian segment of the space station. And we train in all aspects of daily life in the space station, how to run research, how to do repairs, and how to respond to emergencies. So we spend a lot of time working as a team on what to do if there was a fire, a depressurization, or a contaminated atmosphere. We train in some of the more mundane and routine skills. For example, how to use the exercise equipment. So this is a picture of our ARED, the Advanced Resistive Exercise Device in Node 3. And we practice on this piece of hardware so that we can do this on orbit and maintain our bone and muscle health in the International Space Station. And I love this picture because it reminds me of working out on the space station with the cupola, and you can see light coming from the cupola behind me, being able to turn around in between exercises and just see the Earth spinning below. So we do spacewalk training in the pool. And then also under the pogo suspension frame. We do more spacewalk training in the virtual reality laboratory. And then also in the vacuum chamber, so that we can ultimately go outside the space station and safely and successfully repair and upgrade our home in low Earth orbit. So the almost 20 years of human presence on the International Space Station is a testament to the training that prepares us for the daily routine and the occasional emergency that we encounter in space. But more importantly, it's a testament to the hundreds, if not thousands, of dedicated personnel that provide that training, that set us up for success, and then ultimately help us return safely to the Earth. Thank you.
Thank you, Kjell. That was absolutely fascinating. So interesting to understand all the training that you go through and all the dangers one encounters in preparing to be an astronaut. And now we're going to actually switch over to learn about how do we prepare the environments that an astronaut actually works in and functions in, and all that's involved in that process as well. So I'm delighted to turn over the microphone now to Todd May with KBR, who is going to talk about the work that KBR does and he does in creating these environments where astronauts can conduct research and advance human space exploration. Todd.
Hey, thank you, William, and thank you to Space Center Houston for setting up this panel. The wisdom of how you chose the different folks to tell different aspects of this process is really become evident to me as I listen to Ann and Kjell give their stories. I'm going to come at it from a little different perspective. They talk about astronaut selection and what it's like going through a training program from the astronaut's perspective. But my background is more of a career doing development on the spacecraft and launch vehicles that the astronauts ride in. And I now work for a company that trains all the crew and supports NASA, ensuring their health and human performance. A lot of the pictures that Kjell showed, you'll see other people in the pictures that are not wearing the blue suits or the EVA suits. A lot of those folks are our employees and those hundreds of thousands of people that Kjell talked about that help prepare them for the tasks they've got ahead of them. So I'm going to give you my thoughts on some of the other aspects of crew and vehicle integration, or how the crew actually affects the design, and training from the trainer's perspective. With respect to design integration, one of the things we always need to keep in mind when we're building a spacecraft or a launch vehicle is that we're actually building it for the astronauts to live, work, and sometimes play. Humans are very fragile, and space is not our natural habitat. And so every aspect of the design has to have these kind of considerations, whether they're safety considerations, things like noise, the lighting that they have needs to be adequate. You've got to have the right pressure and oxygen levels to be able to simply breathe. The cleanliness of the air and the water, you've actually got to remove toxins that come off of things that come in and out of the space station. Sharp edges that can cut them as they float around. You've got to have considerations for ergonomic design. And we use things like the 5th percentile Japanese female all the way up to the 95th percentile American male. And you've got to be able to have passageways large enough to accommodate the largest in that set, but you've also got to have everything within reach of the smallest within that set. And so that's a different set of design criteria that gets overlaid typical, all the typical spacecraft development design requirements. And then you also have to think about operations and maintenance, particularly on the space station. Every single cable has to be labeled, and all the connectors have to be keyed so that you don't place them into the wrong location, because this space station has flown for over 20 years now, and all these astronauts come up, and we have to make sure that we're able to keep things running, and things do break over time. And fixing things in space where it's zero gravity is not as straightforward as it sounds. And all these things get turned into design requirements so that you, from the very beginning, design for operations and with the user in mind. I spent most of my early career at Marshall Space Flight Center. I worked on the space station modules from design all the way through delivery and activation on orbit. And I also got to work with a lot of the closed loop life support systems like the recycled air and water that you hear about that the astronauts breathe and drink. You know, I was a hardware guy. I considered myself an engineer and a shipbuilder. And you can really get into building the hardware and thinking about schedule and just getting it pushed out the door. But one of the things NASA builds into the process is the astronauts are actually part of that design process all the way through to the end, including coming and checking out the hardware. Kjell talked about actually simulating the work that they have to do on orbit. Well, when we were building the space station, we had not done it before, some of these operations. And perhaps my biggest aha moment was when I was working on the airlock. Crewman Riley, who was going to be the first person to do an EVA out of the airlock and was going to hook up the oxygen and nitrogen tanks outside, was concerned about the markings on some of the connectors that go together. And we had brought him down to show him how easy it was to put these connectors together. And so we would pick them up off the bench and show him how they go together. And then he turned around and explained that when he's out on the edge of the arm wearing an EVA suit and he's making the connection behind him, it's sometimes hard to see how to align the connectors to make them go together. And that was a big lesson for those of us sitting in the room, that just because you can put it together on the bench doesn't mean it's as easy to do as when you're hanging out on an arm with the earth below you, trying to look behind you in a constricted EVA suit. Another big aha moment was I was working on the node, which was the first module to fly, and we have these requirements for noise for all the individual components, but you also have a requirement that when you put them together, they don't create a harmonic and get above what's called an NC50 requirement, or 50 decibels aggregated. And I was having a bit of a discussion with one of the acoustic experts, and he said we had to go fix it and put more foam in, and I told him we didn't have time. So I went over to his office, and we were kind of having a heated discussion, and I noticed I was pretty elevated, and he reached over and he turned the fan off in his room, and he said, "Did you feel your stress level just come down?" And I said, "Yeah, actually I did." And he said, "That's the difference between NC40 and NC50. And imagine these crews have to live and work in this for 24 hours a day, 7 days a week. You really don't want them stressed out due to that noise." And so I really started to understand that you have to incorporate these things from the very early parts of the design. And so that's kind of from a hardware developer point of view. In my role now, I work for a company that does train all the astronauts, and we also do the health and human performance. And so the other side of design integration is from the viewpoint of the user itself. You have to be fully versed in how things work if you're going to fly, and you also have to have the procedures in place for almost every situation and training for almost any contingency. And so my company has trained every astronaut since the 1960s. We train Americans and our international partners. And we are also recently, as William said, we're cleared to begin training commercial astronauts. And so Kjell covered most of the training, but I'll add a few more tidbits from the trainer's perspective. You know, once you're assigned to a mission, the astronauts get about 2 years of either advanced vehicle, payload, and medical training, depending on what their roles are going to be, to prepare them for the specific mission. You know, Kjell showed you some of the training facilities. These things are carefully engineered and designed to be as realistic as possible so the crew can develop the mental and muscle memory for the tasks that they have to do. You saw Building 9, that's the space vehicle mock-up facility. It's actually a physical mock-up of the entire inside of the International Space Station. And you go there to actually work on procedures on the ground, and you'll see trainers standing there with the astronauts, walking them through the procedures and giving them tips and hints. Then there's the space station training facility, where you look at the procedures and the command and control training, so you actually learn how to operate the space station. And then Kjell had a picture of the robotics dynamic skills trainer, where you actually use the ISS robotic simulator to prepare yourself and develop the muscle memory for moving things around on the space station. And then the NBL is an exterior model of the ISS underwater. And you actually train them in the suits, and they learn how to operate the suits in a kind of a zero gravity environment and perform the very complex tasks that they have to do on orbit. And one of the things my company does is we also maintain the suits, and we help fit the astronauts and train them to use those as well. They learn every vehicle system and how to maintain it. They also learn how to do things like basic hygiene. Believe it or not, going to the bathroom in space is a specialty skill, but so is maintaining a potty in space. You actually have to have space plumbers, and some of the more mundane things that astronauts have to do is learn how to keep that potty running. You saw some of the exercise, the running on a zero-G treadmill or riding a bike with no seat on it. Those things all have to be learned on the ground. And not every spaceflight mission has a physician on board. Kjell mentioned crew medical officers, which he was one. They get special medical training. They learn how to do a physical exam. Through the COVID experience lately, you've been hearing about intubation. They learn how to do that. They learn how to suture wounds. They also do dental training. And so it's important for the crew to be very nice to the CMO in case you have to have any dental work done while you fly. You want to make sure you're on their good side. We also have ultrasound on orbit. It's the only medical imaging capability we have, and so we've come up with some really interesting ways and techniques to do that. Those techniques have been pushed out on the ground to be used with Olympic teams now, the Detroit Red Wings, and even some high altitude mountain climbers. Finally, you have to do CPR in space. You need to be ready to do it, and if you think about it, you can't do it like you can on the ground, so you actually have to put your feet up against the other side and do almost a handstand to perform the CPR. That's something that doesn't come naturally, so you have to train for that. One of the things our company also does is we support astronaut health and human performance. We make all the food for the astronauts. They get to come in and taste everything before they fly and pick out their menus. Unfortunately, your taste buds do change in space, and so what they pick out on the ground might not taste quite as good when they get on flight. Coffee is always in high demand. I mentioned that we do recycled water, and so sometimes yesterday's coffee becomes tomorrow's coffee, and sometimes tomorrow's coffee is not just your yesterday's coffee, but the rest of the crew. We also study the effects of the space on the human body. Astronauts get taller in space due to spinal elongation from the lack of gravity. There's neuroocular syndrome. Several years ago, we determined that your vision changes because of the shape of your eye actually changes, and it affects the astronaut population. You have different blood flow in zero-G. It's one of the reasons that pictures on the space station always look like folks are holding their breath. You have bone loss, and you saw some of the exercise equipment. That exercise equipment has physical countermeasures, but it also is a good psychological tool for the crew on long missions. And then we also have exercise regimens that are unique to each astronaut. They're called countermeasures. And then we are developing work for deep space exploration as we move forward. We're going to be developing training for new vehicles like the Artemis vehicle, the Human Landing System, and Orion. Deep space adds additional complexities like radiation exposure, long durations on other planets at reduced but not zero gravity. Also, deprivation and isolation studies and countermeasures become important. As William said, we're also beginning to train our commercial astronauts for new vehicles, and that'll take some specific training for those as well. And we look forward to supporting both of these groundbreaking programs for years to come. That's it for me. Thanks, William.
Absolutely fascinating. That is really quite amazing to consider everything that goes into keeping us alive and well, because it's true, human beings are really fragile, and putting us in this environment that we're not evolved to live in exposes us to all kinds of challenges and dangers, and it's remarkable that you have to design systems and think of processes and ways to keep us well. I guess I would like to cycle back and now ask some questions of the panel, going back to Anne. And it was very interesting in your slides to see the selection committee. And I'm kind of curious to know, who are those individuals who work with you to begin refining that list and getting down to those 50 individuals who ultimately will be asked to come in for a physical test or further conversations about becoming an astronaut candidate?
So absolutely. As I mentioned, it's a multiple phase. There are multiple phases of the process. So we actually start with an initial review from a team of HR specialists looking at right, do the people meet the minimum qualifications? That was the photograph that I showed of a bunch of HR people locked in a conference room and not allowed out. As we progress to inviting folks on site and the astronaut selection board takes over, that group that is interviewing the candidates and evaluating them at that phase is primarily senior astronauts with flight experience that are, right, know what it takes to do the job, are really evaluating the candidates based on some established criteria that we talked about: teamwork, followership, leadership. Can they communicate effectively? But from an astronaut perspective, and Kjell may want to comment on this, I think they're also trying to figure out, would I want to go to space with this person? Do I get the sense that I could put my life in their hands and that they'd make good decisions, et cetera? And right, as we look at going further and further into the solar system, you know, and going to Mars, could I be in a spaceship with this person for an extensive period of time? So we really do rely on the astronaut office to help narrow that well-qualified field down and make recommendations on who would be the best candidates to bring into the office.
And I'll agree with Anne. You know, first of all, we're immensely grateful for HR's help kind of whittling that field down. But as she mentioned, that really is kind of the bottom line, that as we meet with these different applicants, you know, the question that is in the back of your mind is this somebody that I could spend 6 months with in a confined area and have a successful mission? And of course, you know, the people that we bring in to the Space Center for interviews are all absolutely have amazing backgrounds, and so we are very, very fortunate to be able to choose from really the best that the United States has to offer. I would say just one other addition to that is, boy, the burden that you feel as you're selecting this next class of astronauts, this next generation of astronauts, is a considerable one. You know, as we were having our discussions and identifying our top candidates, you recognize that not only are you choosing people that you're going to be working with, but you're also choosing the future of the astronaut office, the leaders of tomorrow, and that's a pretty impressive burden to bear.
Well, I think we're in a time when the general public can probably relate very much to living with someone for an extended period of time in semi-quarantine, since we're all going through kind of self-quarantine at home during COVID-19. So I think that's a very relatable point right now. And it's something I find really extraordinary that you all have to consider in selecting candidates. I'm wondering, we often hear that there are candidates who have applied multiple times. And Anne, I'm curious if there's an average number of times that many of your successful candidates have applied. And Kjell, did you have to apply more than once before you were selected?
So there are candidates who have, I think we've kind of seen a little bit of everything from candidates who apply the first time and get selected. The highest number of applicants that I think I'm aware of is around 15 or 16 times applying before getting selected. So we see the whole range. Certainly, right, as you progress through your career, you pick up more experience, et cetera. And so, you know, that can impact an individual's application package. And so we've really seen everything from applying the first time and applying numerous times. Since we have stopped flying the space shuttle, we run selection processes approximately every 4 years. Historically, during the shuttle era, we used to run selection processes really every other year. And so I think we saw a lot more candidates back then applying time after time after time. Now with a little more distance in between the selection cycles, you know, we see a little bit less of that.
And for my own experience, I am very grateful. I was selected on my first attempt, but I also waited until I felt like I had accumulated a critical mass of experience and education to be at least qualified to apply. And I know that there are some folks that may be applying. I think Ann spoke to that a little bit in her introduction, that there are some folks that apply maybe without the necessary academic background. But I would actually be interested to know from your perspective, and if there is any harm in applying before maybe you're absolutely qualified.
I don't think there's any harm, and to that end, right, you're constantly revising your application package. It's something that can build and grow as an applicant accumulates more career experience. We also have individuals who get invited back for interviews more than once before being selected, and certainly any practice, sitting in that interview chair. I like to say it's like any old career interview, right? We're asking normal interview questions, but I can't imagine the pressure and the intensity that one feels when you're sitting there interviewing for some of them for the dream job of a lifetime. So we also tend to see people who come back and interview a second time with a little bit more ease because they know what to expect and they know how to, kind of portray themselves as a real person.
Yeah, and I absolutely agree with that that description of that experience. It does feel like they're fairly standard interview questions, but that the stakes are high. And I would say, just the experience for myself, being invited to come and do an interview, to be a part of that first round of interviews, and then to be invited back, just that experience alone was absolutely amazing. And I had no expectation that I was going to make it to the second round, much less get selected. And so I really looked at it as, boy, these 10, 20 people that I've gotten to hang out with, this has been an amazing experience. I've gotten to meet some amazing people. I'm really looking forward to that, one or two of these folks and watching their career as they make their way through a space station flight. So it is an extraordinary experience just getting to go through the selection process.
Well, I have to say, it sounds like Star Wars was inspired for Jedi training by learning what astronauts have to go to be selected and trained, because of all the preparation that you have to go through to be placed in different kinds of environments. Todd, I'm curious from the design side for these environments to support astronauts, do the designs that KBR comes up with in supporting and training astronauts are they actually used in the selection process? Are some of the technologies or other kind of training that you do, is that actually informing some of the training that takes place or selection process for astronauts?
Well, let's see. I don't know that it's informing the selection from our perspective, and Mike could speak to whether it does that. But I will say that the facilities that we've used throughout the years have gotten more and more evolved, and the training that we do has shifted depending on the mission. So if you think back to like the Mercury program, we were simply concerned about whether humans could actually be able to live and work effectively in 0G. And then when you got to Gemini, you added the complexity of EVA and rendezvous and docking. And then on the Apollo program, the lunar landing and the ability to be mobile on the surface of another planet. And then when we went to the shuttle program, you had winged flight, especially on the return. And then on the space station, it was long duration, very long duration operations and maintenance. And now what's really interesting is with the Artemis program, it kind of comes full circle again, and we're going back to the kinds of things we looked at for Apollo. But when we talk about going to the moon to stay, living and working on the surface of another planet for long durations.
There was something that both Ann and Kjell referred to that really caught my attention. We always talk about the importance of leadership, right? And there's a lot of focus on leadership training and how you, of course, develop and work with teams, all very critical and important. But you both referenced followership. And that's not a term we often hear around excellence and performance in teams. And I'm wondering if you both could just speak a little bit about what followership means and how do you identify that quality and engender that quality for success among astronauts and fulfilling their missions.
You know, I think in order to have a good team, you need to have, clearly you need to have a leader, but you need to have folks following that leader. And I think in the groups that we select to become astronauts, the folks that we select to become astronauts, there tend to be a lot of leaders, a lot of people that have excelled in their fields, that have led teams, led organizations. And so when you bring all those folks together, you can't have a team of all leaders. Everybody's going in a different direction. And so it's important to, depending on the situation, depending on the assignment, have somebody that has the necessary training and is leading that team. And you have other individuals that are doing whatever they can to make sure that that leader and that team is successful. And so it's really having a mission success priority, understanding what it is that you're trying to accomplish, understanding that the leader has that in mind, and everybody else providing fulfilling their own roles to make sure that the leader and that mission is successful. And then maybe, Anne, you can talk a little bit about how we look for that.
Yeah, I think to add a little bit, Kjell, to what you said also, right? If I think about the role of the astronaut in a spaceflight environment, a lot of what the astronauts are doing is following instructions, right? If I think about working on experiments that a principal investigator has designed and has concrete steps established, right? A lot of that fits into that followership category. In terms of how we look for it, right? That's hard, but as some of the pictures I showed, we try and set up, in addition to the interview, we tend to focus a lot on the interview in various failure situations, failures of leadership, or examples of failing as a team member and what they learn, to see how, if they have self-awareness such that they can recognize those and learn and grow from those. And some of the activities that we structure for them when we get to the interview phase as well, we're also setting up various scenarios where we assign folks to be both lead an activity and then put them in different situations where they're following another leader and try and assess to the best of our ability how they go with switching those roles. Can they switch from being the leader to the follower in fairly short order? So we do our best to kind of learn what we can in a short window of time about candidates' capabilities to kind of switch those roles.
Todd, I'm curious about when an astronaut's preparing for a mission, you often hear that it takes years. You heard Kjell talking about this training in MBL and other kind of environments. How do you design that training when you know that an astronaut is going to be doing a particular mission? It may be a repaired International Space Station or some other type of kind of key mission. How do you approach the design of that kind of training and preparation for that activity the astronaut's going to be doing in 1 to 2 years from now?
Yeah, that's a really good question. It kind of goes back to the design phase. One of the things that I remember was built into the design contract for the prime contractors who built the hardware on the space station were any operations and maintenance procedures, but they were to be written for the ability to do it, of course, in zero-G by the crew. And so I think it kind of starts with you take those documents and you then decompose that into a training curriculum or a particular class on an item. So, let's say, for example, the space station, the way most of the electronics are cooled are by these cold plates, and there's a single loop of it's called ITCS. It's a water-based fluid that flows throughout the entire space station, and those cold plates, the hardware sits on them, and that heat is transferred to the water in the cold plate and then goes out to the radiators and is radiated out to space through an ammonia loop out there. But when we first started building the node, we got some leaks in the cold plates, and we were worried that they really originally had not been designed to be easily removed from the racks, and so we actually had to develop not only the solution to the leaking, which we eventually did, but also the procedures to be able to remove those. And so those turn into a training module for the crew in the Building 9 environment, where you have mock-ups of the racks in there, and you see those trainers standing around with little procedure documents, and the astronaut is put in front of them, and they're walked through the procedure and given, like I said, given the tools and the tips to be able to do that, to develop the muscle memory and to know the special tricks. There's actually a pretty interesting story around that particular thing. The fittings on the cold plates are called gamma fittings, and there's not a nut, but a washer that goes on there. And the way you put the washer on, when you tighten it down, it coins, and it actually sticks onto the fitting itself. And if you just try to pull it off, you could damage the fitting. And so we were struggling with how to do that. And to Ann and Kjell's point about how amazing some of these astronauts are, to have made it through all these steps. Don Pettit, one of the most Renaissance men I've ever met, was in the meeting, and he heard us all struggling with what to do about this. He went home that night in his garage and built a nylon and copper little tool that he came back the next day and stuck it on there and spun it around, and the washer came right off, and it turned out that became the design we used on orbit. And so he kind of trained us on that one. But again, it just kind of goes back to, you take the design, you look at what it takes to operate and maintain it, and then you build that into a curriculum and do the training. And if it's on the inside of the vehicle, then you do it over in Building 9. And if it's on the outside and you've got to do a spacewalk, you go over to the NBL and you practice it over there.
Well, Kjell, I'm wondering if you could share, I imagine you have many training stories, things that, experiences that you had, and I imagine that everyone you walk away with new insights, new perspectives, etc. But I'm wondering if there's a particular story or two that you could share with us about training and some insights that you gained.
Sure. I think it really will speak to the training process overall. And it also answers a question that I frequently get, which is, what was the thing that surprised you most when you get to the International Space Station? It's interesting because we train in this gravity environment, and we do our very best to learn all the things that we need to do, how to repair the toilet, how to cook our meals, how to build a spacesuit to prepare for a spacewalk, and yet we do that all on the ground. And so it takes some time to adjust to being in weightlessness. It's the one thing that we really can't train for, and it's one of the most overwhelming changes that occurs, the biggest difference between what we do on the Earth and what we're doing in the space station. But for me, one of the most surprising things that I encountered when I got to low Earth orbit was that despite this huge change of being in weightlessness, I felt prepared. Everything that I was asked to do, every activity, every event, I felt pretty confident and qualified to participate in that thing, to undertake it. And so that's pretty amazing when you think about it, that whether it's training that was provided on the ground or training, just-in-time training that's provided on orbit, that our teams of instructors and engineers have really provided us all of the resources that we need to be able to undertake whatever task is set in front of us. And so I think that was the greatest surprise. And so maybe we overtrain a little bit, but that's not a bad place to be, so that we are not, increasing the number of mistakes, for example, that we're making on orbit. The other part of it is, I already mentioned, was just when you sit back and think about all of the training that has to be accomplished before you're ready to fly in space, so that not only do you know how to do the research that some principal investigator that has sent their research up onto the space station, that they maybe have worked their whole career for that one moment that when you touch their experiment. Anywhere from that to knowing how to change a light bulb without shocking yourself. I mean, think about going through a day in your house and every single thing that you do, you need to receive training on that. That's a massive amount of training. And so the fact that when we get to the space station, that we're prepared for all of those things, some of it we have internalized and know how to do by rote, or some of it we know exactly where to go to find the procedure to be able to accomplish it. That's a pretty amazing thing.
And I'm curious, of course, NASA's priority right now is the Artemis program and the return to the moon. Are there particular qualities that were being sought in the last round of astronaut recruitment? Because I'm presuming the last class, some of those could be candidates who ultimately will be assigned to an Artemis mission in the future. Were there different characteristics that are being sought for that return to the moon mission compared to astronauts potentially being assigned to International Space Station?
Sure, that's a common question. And if we look back even to the class of 2017 and the current selection cycle, right, which we're just at the very front end, the application window, again, just closed at the end of March, really the characteristics and competencies that we're looking at through the selection process haven't changed that much over the years. Again, we don't see many people, or really any people, coming and applying with previous astronaut experience. So we're looking for some of those everyday job competencies that Kjell and I have both mentioned, right? Leadership, followership, communication skills, teamwork is of critical importance. I think the other thing that we take into consideration throughout the selection process is that everyone's coming to the table with a technical discipline. And so with that in mind, we look at kind of the full spectrum of the astronaut office to really make sure that we have the technical competencies for the chief of the astronaut office to be able to assemble the needed components of a crew, regardless of if it's going to the moon or to Mars, right? We're not going to send all of the same skill set on those missions. So for us, from a selection standpoint, we're again trying to make sure we have multiple competencies across several technical disciplines, whether biological sciences, right? Kjell being a medical doctor, physical sciences, geology may be important as we go back to returning to the moon. Engineering competencies, right? The ability, as Todd mentioned, of Don to engineer something and fix something in a real-time scenario. So I think that all plays in to the role that the selection board plays, is making sure that the right pieces of the puzzle exist within the crew office for them to assemble the crew based on whatever the mission is.
I have a question about the role the general public can play in helping to prepare astronauts for space exploration. We know that there are the Hera projects, where the general public can volunteer and can live in isolation, et cetera. Todd, I'm curious, how do you develop the protocols, and how can the public play a role in helping inform the research that KBR does, and the habitats and the training structures that are put in place to help not only in the selection but also preparation for actual astronauts?
Wow. I don't know. When I think of public involvement, there's two major fronts I see for NASA. Actually, three. One is simply advocacy for NASA and our mission and exploration, the cause of exploration. Because I think it kind of going back to the charter of NASA, it's for all mankind. I think number two, and actually out of Johnson Space Center, there's some interesting data around this, but there are a number of challenges that are put out there to the public that anybody can respond to, and we have found that we have gotten some great responses. I remember one with respect to EVA tools, a handrail design. It went out, and I think that NASA got maybe 200 plus different designs, and 20 something of those designs were deemed better than the current internal design. And then I think the third is to, especially for parents, to to encourage their kids in STEM, because that is the engine that actually powers the innovation that what NASA does. The children that study STEM are the ones that end up being the engineers and scientists that design the spacecraft, that develop the payloads and the science experiments, and become astronauts of the future and operators of space stations. And so those are three fronts where I think the public can definitely get involved and stay involved in what NASA does. NASA, I think, does a great job with outreach to the public, and the public in turn is very supportive of NASA and its mission. Those are my initial thoughts.
Well, Space Center Houston is very involved in having the general public be involved in helping NASA advance its mission and come up with solutions. Through our website, you can learn it through our Innovation Gateway about challenges the public can participate in, all of you, but also we're working with NASA on the Space Robotics Challenge. Applications are closed and we're in the qualification round, and we'll be announcing progression on that later this year. So I'm curious, because we're getting close to the end of our time, if each of you would like to share your thoughts on how you hope space exploration is going to actually help benefit humanity as we progress into the future.
Well, I mean, I think that we are at a really exciting crest of space exploration with the development of these commercial spacecraft, with the SpaceX Crew Dragon, the Boeing Starliner, and starting to roll those into actual operation and supporting space station operations. We're bringing these commercial companies alongside and providing the infrastructure for them to kind of flourish on their own. And so I think that we've had some commercial space flight in the past with space tourists visiting the International Space Station. I think that we're really on the cusp of seeing this next generation of commercial astronauts and commercial space exploration. And that's really exciting to think that what 3 nation states have accomplished in the past, now we have American commercial companies that are going to be able to support that capability as well. And I think that it's really providing the impetus for exploration, for that return to the moon, for the exploration of Mars. And so it's really exciting to be a part of what's going on right now.
I'll go next. Certainly this is an exciting time period for NASA. I'm excited to be a part of it, and I'm excited at what's on the horizon. If I think about sending the first woman and the next man back to the moon, that's exciting all around. I think it really has the capability and possibility to excite hopefully the American public about the STEM disciplines and about all of the many things that NASA is doing across its entire portfolio, not just human spaceflight. If I break it down to things, I've been thinking about this a lot as we've been in this quarantine situation. For me, it's a really exciting time to be doing an astronaut selection. I hit upon that earlier, right, of reading thousands of applications from really amazing Americans from all different types of STEM disciplines. And right, it leaves me very hopeful that there are so many smart people out there who want to be astronauts, who are pursuing great things in their current fields of expertise. And so I'm just really optimistic about what is ahead for the world at large, and certainly for the missions that are awaiting NASA as we go back to the moon and hopefully on to Mars.
And I think Kjell and Ann summed it up pretty good. I will add that I've always felt like exploration is kind of written on our DNA. It's something that we were born to do. And if you think back to your childhood, you were doing it when you were a kid, when you would climb over the fence or land at a new place and go look around. And so I think what NASA does is satisfies that curiosity and enables out on the frontier discovery of new solutions and new things about our place in this universe. And you know, with something like COVID going on right now, I always felt like when I was at NASA proper that NASA was always this uplifting storyline that, you know, in the midst of war or disease or tough economic times, you know, NASA discovers Pluto and finds out, you know, hey, it's red. It's nothing like what we thought. Or we see a new galaxy through the Hubble Space Telescope, or you know, we land on another planet for the first time. Those are things that draw us together, much kind of like COVID has in a negative way. It draws us together as humanity in a good way, and that's exciting to me. That it helps remind us that we here as humanity on this planet can work together to achieve amazing things and push our boundaries further and further.
Well, I now want to say thank you so much to our panelists, Anne, Kjell, and Todd, for sharing your perspectives on astronaut identification, selection, and training. This has absolutely been fascinating. We could go on for much longer, I'm sure, so I have many more questions. But we really appreciate you spending some time with us today and sharing your insights, and for all you're doing to advance human space exploration and all the great benefits it's creating for humanity. Space Center Houston is delighted to bring you this Thought Leader series presented by UTMB. And we're looking forward to our June program, and we hope that you'll join us then when we talk about the human-robotic interaction. Until then, thank you for joining us.